Hello and welcome to Buildings of Tomorrow. My name's John Lester, and in today's episode, we're talking about hydrogen. And is hydrogen really the path for us towards sustainable heating and sustainable combustion in the future? I'm joined by Burkhard Maier. He is the General Manager for Combustion at Siemens Smart Infrastructure. Burkhard, thank you for joining us.
Hello, John. Thanks for the invitation.
Beautiful. It's an absolute pleasure, Burkhard. We're excited to talk to you about this because I think combustion is one of these topics, one of these heating topics in the industry that not everyone is really aware of the extent, the importance of this part of the industry in our daily lives. And that's where I wanted to start with you today. I wanted to ask you for a quick crash course. And when we talk about combustion and the combustion industry, what do we mean? What are some of the key use cases that we see out there on a daily basis?
Yeah, combustion simply means burning gas and oil for heating purposes, for residential buildings and commercial buildings, but also for the use of industry applications, for example, in the glass industry, painting industry. And we use boilers and burners for gas and oil combustion. And if you hear gas, it is not the natural gas alone, it's also biogas, and the more and more it will also become hydrogen. And what we are doing is that we provide components to manufacturers of boilers and burners, which at the end is an OEM business.
Perfect. Thank you. I think that's important because not all of us realize, if it's the central heating in your apartment building or your district heating, but also, the creation of heat or steam for different manufacturing processes. This is the industry that we're talking about, and it's a very huge piece of that heating infrastructure in our societies in general, which is why it's such an important topic. And also why it's exciting when we start to talk about hydrogen. And let's jump in there straight away because hydrogen is somehow an exciting topic at the moment. Everyone is talking about hydrogen, whether it's to do with high energy prices, whether it's to do with reducing the CO2 impact of some of these pieces, or whether it's trying to localize and develop energy solutions in different places in the world. From your perspective, how important is hydrogen? Is it really the next step? Is it going to be an alternative for some of the more common heating gas elements, like you mentioned before, natural gas, biogas?
Yeah, if you compare hydrogen and natural gas, look, natural gas is a natural resource and it's a limited resource. It was built 3.5 billion years ago and is now in a depth of 1,000 to 7,000 meters. And we have to bring it up, and it will never be in that form in the future again. So after it is burned, it's lost. And that's the difference to hydrogen. So hydrogen is today on the Earth mostly binded in water, in simply water, together with oxygen. And it's also a natural resource. But if you burn it, you do not have in the emission CO or CO2, which is responsible for the climate change. As an emission, you just will have water vapor, and this will return to the nature water cycle afterwards. So this is the biggest difference of hydrogen and natural gas. But what I must say, hydrogen can also be used similar to natural gas. So for those combustion purposes.
And I guess that's the exciting part, isn't it, Burkhard? You have a huge difference in the gas that is, the waste product, let's call it. You don't have CO, you don't have CO2. And it is somehow, while a natural resource, we don't have to dig for it, we don't have to drill for it. But at the same time, it will more easily and more naturally go back into the cycle. Sometimes when we talk about hydrogen, people get a little bit concerned about safety because hydrogen is known as a volatile gas to a certain extent, at least for the outside in. Someone sitting in my situation who's not an expert, how much of a concern is that, the safety, when it comes to hydrogen?
So I would say Burning and handling hydrogen is no more dangerous than handling natural gas. And with natural gas, in terms of safety, we have many years of experience. So to store it, to burn it, and also for the transportation of natural gas. And nowadays, there are a lot of standardization committees all over the world, especially in Germany and in Europe, I know, where they are currently adapting the regulations from natural gas to hydrogen. And to be honest, hydrogen to use as an energy carrier is not new. In the mid of the 19th century, it was used town gas made from coal. And that consists out of around 50% of hydrogen already. And they used it first for street lamps and afterwards for cookers. And in the second half of the 20th century, the town gas was then replaced by the natural gas.
Understand. So nothing new, no risks above and beyond what we're used to somehow. So we know how to do it. We know how to handle it. We know how to use it. Then let's take to that next step. And you mentioned it before. Hydrogen doesn't have the same emissions that cause us some of the concerns around climate change, around the heating of the atmosphere. So how can it do that? What's the process, and how is it important for us to take this step?
Yeah, there are various ways to produce hydrogen. And the most interesting one is the electrolysis. What do we do there? The water we take is split into hydrogen and oxygen by using electrical current. And if you now use green electricity coming from wind turbines or photovoltaic, then you have an absolute climate-friendly energy carrier. And then you can store it, transport it, use it, and you're totally climate-friendly. That is also called the power-to-gas solution.
Yeah, and let's look a little bit more at that, if that's okay, Burkhard. Because, as you mentioned, electrolysis, one of the key production methods, solely, and electricity, of course, is something where we have a huge focus for many of the other consumers within the energy grid, let's call it. How is that connected? That you mentioned green energy. How important or how closely can green energy and hydrogen production be linked?
If you look at it this way, I would say green electricity can only be produced economically in combination with hydrogen. So if you see at the graphs which show the production of electricity, and then in the same diagram you could also add the consumption of electricity, you understand that the more you use renewable energies, depending on the weather, wind and the sun, the more you will have peaks with surplus energy, which at the moment sometimes cannot be used. It's wasted. Everybody knows the situation. You're passing a wind turbine when the sun is shining and also there's a lot of wind and the turbine is not working. And you ask yourself, why is that? Now we could produce so much electricity, green electricity, and this machine is not working. And the only reason for that is that it is not so easy to store so much power when we have the surplus electrical power. So there comes the use of hydrogen. If in those situations the surplus energy would be used for the electrolyzers, which then start and produce hydrogen, and you would then inject the hydrogen into the gas grid, it wouldn't be lost and you could use it for other purposes as an energy carrier.
Amazing. So a little bit of a win-win. We have a combustion process which has a different exhaust, let's call it, a different exhaust gas that doesn't have the same impact on the environment. And that's even if you don't take into account the fact that we need to drill something up in one part of the world, put it on a ship, and ship it to the other side of the world. So already a win from that perspective. And then adding some resiliency and adding a way to consume and store in gas form the energy produced via renewable energies, wind power, solar power, etc. So that sounds right. It sounds good. So now when we talk about the real components, so the boilers, the burners that you mentioned before, whether they're in industrial or residential applications, what's the process? How do we really go to today from component powered by natural gas to tomorrow being powered by a hydrogen gas?
Yeah, as you are saying, one is depending on the other. So the production of green electricity is the pre-consumption to produce hydrogen, and that needs time, and it also costs money to build that up. And therefore, the best would be if we work on several technologies at the same time. And then we expand them successively and use them in combination. When I say combination, I mean the different sectors. So it's electricity, it is heat, and also transport. And if we this take in consideration together, we are talking about the sector coupling or the integrated energy. And this, for me, is then the energy transition to use open, and we are open for every technology. There is not the one and only solution. No, we should use several ones, and one part of it is hydrogen, which fits ideal into the whole complex situation.
Understand. And as you mentioned, we need to work on different technologies. We need to try some different things and work on different parts of this energy transition to make it happen. How would that look from your perspective? How would you imagine the switch from where we are today to a new energy source looks?
Yeah, it's in many cases the same situation with new technologies. So you have a chicken and egg dilemma. You have to create one as a prerequisite for the other to emerge, and you are afraid to do the first step. But in this case, with hydrogen, it's much easier. First, you can use a mixture of natural gas and hydrogen. So as soon as you have that surplus power available, you can immediately produce hydrogen, inject it into the grid, and you can use it. Then second, the gas grid is already existing. You do not have to build up for a long time and start in a pilot area or something like this. You can immediately start and distribute what you will have. And then the third is that the gas consumers, so the gas boilers and burners, they are also already prepared for the consumption of a mixture of natural gas and hydrogen. And at the end, of course, we want to come to a situation where we have 100% of hydrogen in the grid. But there, the current situation is that we would need a conversion kit. There's a setup of the controller, usually a change of the burner and the sensor. But this is the current situation. Where we want to go is to have a very flexible solution, which is then from 0% hydrogen to 100% hydrogen automatically convertible.
Understand. And as an industry, if we talk about this mix or this scale from a small amount of hydrogen mix back to 100% hydrogen mix, how do these appliances, like you mentioned, the consumers, the boilers, the burners, how do they react to this? How you mentioned some conversion but this is not always the case. How do we know, as an industry, what's happening to enable this shift within the real appliance level?
Yeah, John, this is a very good and also very important question. Where you are not the only one asking him this question. There are researchers all over the world how to use hydrogen and what will be the impact on the gas appliances. For example, in Europe, there's the Clean Hydrogen Alliance. They have 750 projects in the pipeline, and those projects are for the various sectors. They are for production, distribution, industrial applications, mobility, and of course also for buildings. I myself am involved in a working group for domestic applications. And what they're doing, they are now rolling out those projects, are testing the impacts. They start from, for example, in one area with 1% of hydrogen, taking care what is happening, making testings and so on. And you can read everything in the internet. It's public. You just type in European Hydrogen Alliance, and then you will find everything. Uh, what I think is also very interesting and what is for me personally a very important sign that all the different states working on this hydrogen alliance are offering huge fundings for those projects. So they really want to go there. They are very interested what is happening with hydrogen, and they want hydrogen as a new energy carrier. And coming back to your question, to be more specific, so what we know so far from those projects already is that a mixture of 10% hydrogen with natural gas means no problem for the most of the consumers. And even 20% is in most cases no problem for all the gas appliances. Do you know why? Because, very simple answer, for the certification of a boiler, you need to do a test with a test gas containing 23% of hydrogen. So it is already tested for a part of the further use with hydrogen.
Right. Every component that has this certification has anyway been tested with up to 23%. So we know we can go to that extent without any challenge. That's really positive. You mentioned many different things. There are 750 projects happening, and they're across many different industries, not just heating, but mobility and others. What are some of these other technologies? What are some of these other exciting things, not so much in different industries, but across the heating industry rather than gas-fired boilers? What about heat pumps? Are there any other applications where hydrogen can add this sustainability benefit and still deliver the performance expected?
Yeah, I think for new buildings, at the moment, most discussed solution, and it's also getting more and more common, is using heat pumps. So electrical heat pumps using an air source or ground source to include the environment, heat out of the environment. That's also very good to do so. But for existing buildings, there you have some more challenges which cannot be covered by heat pumps at all. So, for example, the changes within the building to insulate the building, to change windows and so, you do not have to do anything if you use hydrogen. You also need a higher flow temperature in the system, in the heating system, if you have radiators. And this is no problem with hydrogen. And I would say the ideal solution for existing buildings will be hybrid systems. Hybrid system, that means a hydrogen boiler and electrical heat pump. And I'm sure this solution combines the best out of the two solutions and will increase rapidly in the future. So there will be a huge interest in the coming years for those hybrid systems.
More and more. And that's, I guess, one of the things that we're excited about in general with the industry. As the applications become more popular, as the implementation becomes more widespread, we have that real opportunity, like you mentioned before, the chicken and the egg. Whether it's the creation or the generation of hydrogen or the increase in demand for it, it will result in these steps forward. And Burkhard, Today, really exciting. Thank you so much for the conversation. But I have a personal question for you. From your perspective, what do you think? Is hydrogen the way forward? Is this going to be the standard for us in the future to bring those benefits that you described? Is this the way forward for us?
Yes, I'm really sure hydrogen will be used also in buildings. Why that? Because first, the gas grid will be a storage for an economically production of green power. Then the second is you have a very stable and easy use of hydrogen as an energy carrier in the building. And the third, you shouldn't forget fuel cells. So fuel cells in the future also in the buildings, not just in cars, will in parallel produce power and heat. And this is needed when we want to change to 100% renewable energies. But to be honest, the buildings will not be priority number one because there are some sectors where there's currently no other solution than hydrogen or gas currently. That's industry and mobility. So if we have to choose, then the buildings will be, I would say, the third priority. But on my personal opinion, it will be the case that the hydrogen will be injected into the grid, and then it doesn't matter where it will be consumed. And I still know that the hydrogen will be one part of the future. So in combination with other technologies, then there comes the real advantage of hydrogen, and it will not be the one and only solution.
Perfect. And like you mentioned earlier today, one of the big things that enable us to really implement this kind of new technology broadly and effectively is having these alliances, like you mentioned, the European Clean Hydrogen Alliance. These things are such an important part of us driving this as an industry as a whole. And that's what I think is going to be one of the really exciting opportunities. As you say, 750 projects. We know that a certain proportion of these will really result in an impact in our daily industry or our daily lives, which is really exciting. But Burkhard, thanks so much for today. A really interesting conversation. Not the last conversation. We've kind of scratched the surface of the hydrogen topic. I'm excited to talk more about some more specific applications, some of the large scale plants and these kinds of things that we can talk about at a different time. But until then, thank you so much. It was a real pleasure.
Yeah, thank you, John, for the opportunity to report in this podcast about hydrogen, which has become my passion already. And I would be happy to come back and we can talk further. Thank you, John.
Bring it on. Thank you, Burkhard. And thank you also to everyone out there who is listening or watching us. Remember to like, share, comment on this episode. Subscribe to us either via the podcast channel or via YouTube, wherever you happen to be watching us. And hey, always look out for new episodes as they come every other week. And until you hear us again or see us again, we'll see you very soon.